Hey and welcome. Every single time you check your email, stream a show, or just browse a website, there is this powerful, totally invisible engine humming along in the background. Well, today, we're going to pull back the curtain on that engine. It's called the client-server architecture. All right, let's get into it.
Seriously, just think about that for a second. How does your phone or your car or whatever instantly pull up your favorite songs? It honestly feels a bit like magic, right? But it's not. It's actually a brilliant and surprisingly simple idea called the client-server model. And by the end of this, you're going to get exactly how it all works.
So, first things first, we got to meet the main characters in this story. We're going to break down the core idea and introduce you to the essential parts that make, well, your entire digital life possible.
At its absolute core, it's all about a relationship. You've got one side that asks for stuff, that's the client, and you've got another side that provides the stuff, that's the server. It's that simple. Your phone, your laptop, your web browser, yep, those are all clients. They're constantly making requests to these powerful centralized computers we call servers.
And it really just breaks down into three main parts, okay? Think of it like ordering at a restaurant. First, you've got the client. That's you, right? You're deciding what you want and you're placing an order. Then you've got the network. This is like the waiter who takes your order from the table all the way to the kitchen. And finally, the server. That's the kitchen itself, the powerful engine in the back that actually cooks your meal and sends it back out. Client, network, server.
Okay, so now that we know who the players are, let's look at how they actually talk to each other. Because that's what this is, a constant, super fast digital conversation that's happening millions of times a second all over the world.
And this just lays out the whole dance perfectly. It all starts when you do something simple, like click a link. Your browser, the client, shoots a request out over the network. The server for that website gets it, figures out what you're asking for, and grabs all the necessary data. Then, it sends a response zipping back across the network, and bam, your browser catches that data and displays the web page for you. It's simple, it's elegant, and it's ridiculously fast.
Now, this digital conversation isn't just random yelling. It has very specific rules. Think of protocols like HTTP as the grammar of the internet. It sets the rules for how messages have to be structured so everyone understands each other. Then you've got DNS, which is basically the internet's giant address book. You type in a friendly name like wikipedia.org, and DNS translates it into a numerical IP address that computers actually use to find each other. And finally, you've got ports. Think of these as specific loading docks on a server. So when your web request shows up, it knows to go to dock 443 for secure web traffic, not the dock that's reserved for email. It makes sure every message gets to exactly the right place.
So this basic idea of a client and a server is really powerful, but it definitely hasn't stood still. Over the years, it's had to evolve to handle bigger and way more complex jobs. Let's see how this simple idea got totally supercharged.
Way back in the day, we had one-tier systems. You can think of a program like Microsoft Excel. Everything, the interface, all the number crunching, the data, it all lives on your one machine. It's simple, sure, but it just doesn't scale. The two-tier model was a nice step up, separating the user interface on the client from the brains and the data on a server. This was better, but it still had some serious limitations. But this is where things get really interesting. The jump to the three-tier architecture. This is the standard for pretty much all modern web applications. What it does is introduce a dedicated middle layer, the application layer, that handles all the business logic, all the thinking. And here's the aha moment. This separation is what lets the internet scale to billions of people. It means developers can update the core logic of an app on the server without ever having to touch the app on your phone. It's kind of like being able to upgrade a car's engine while it's still driving down the highway. And for the truly massive, complex systems out there, it doesn't even stop at 3 layers. We get what's called N-tier architecture. All this really means is adding even more specialized layers, where each one has a single dedicated job. You might have one layer that does nothing but handle security, another that's just for caching popular data to speed things up, and another that just balances traffic. Each layer does one thing and does it incredibly well, and that's what allows for the mind-boggling scale of platforms like Amazon or Netflix. So, as powerful as this model is, it's not perfect. Like any kind of engineering design, it comes with its own unique set of strengths and weaknesses, and it's pretty important to understand both.
The biggest advantage, by far, is centralization. It's just so much easier to manage, update, and secure everything when it's all in one place. But that's also its biggest challenge. If that one central server fails, everything stops. That's the classic single point of failure.
And in the same way, if way too many clients make requests at once, that server can become a bottleneck, slowing everything down for everybody.
All right, let's bring all this theory back down to earth. This isn't just some abstract concept. This architecture is literally running your entire digital world every single day in ways you might not even realize. So, the most obvious example is just browsing the web. Every single tab you open, every link you click, that's your browser acting as a client, sending a request to a web server somewhere out there in the world. Or how about email? Your Gmail app is a client that is in constant communication with Google's servers. It's always checking for new mail, sending you replies, and making sure everything is perfectly in sync no matter what device you're on.
And for something really high stakes like online banking, this model is absolutely critical. Your banking app makes these super secure encrypted requests to your bank's centralized, heavily protected servers to make sure your financial data is both 100% accurate and completely safe.
And then you've got the biggest scale of all, cloud computing. Companies like Amazon Web Services run these gigantic server farms that provide resources to millions of other applications, which all act as their clients. A huge chunk of the internet you use every day is actually built on top of this client-server foundation.
So there you have it. From a simple click to the global cloud, it's all powered by this fundamental back and forth between clients and servers. You know, you've probably made hundreds of these requests without even thinking about it, just in the last few minutes. It really makes you wonder, as our world gets even more connected, what's the next evolution for this invisible engine that runs it all?